communication. Actually, this is the process that we have in all communication in the TCP IP model. All right, now we have reviewed the network device communication in accordance to the OSI and also TCP IP model. In this class, we will learn more than this about the, for example, layer 2, layer 3, layer 4, and also some applications. Because of that, step by step, we will learn more than before about the network device communication. You know that layer 1, layer 2, and layer 3s are related to the media, and layer 4, layer 5, layer 6, and layer 7 are related to the host, because you know that application and also transport functionality are occurring in the host. And after that, we are using the, for example, addressing, like the layer 3 addressing, layer 2 addressing, and also converting the bits to the, for example, the physical optical pulse, the electrical signal for sending traffic to other systems. Actually, we are using these 4 layers, layer 4, layer 5, layer 6, and layer 7 in one host. But for communication, we are using layer 1, layer 2, and layer 3. For example, as you have learned in the CCNA class, when we are when we are communicating inside of one network, okay, we are using the, for example, layer 2 communication. Layer 2 communication or layer 2 forwarding means communication intra-network inside of one segment. We will learn about them more than before. But when we are talking about the layer 3 communication, means we are talking about the inter-network communication. For example, let me to review. You know that in one network we have multiple PCs, PC1. I will show you multiple scenarios, but we are here reviewing multiple PCs. They are connected to, for example, one switch, okay, and they can communicate with each other, okay, inside of one network. Also, if you want to communicate with other networks, you need a router. In most cases, a router, because you know that some switch, like the multi-layer switch, can communicate between the networks. But now let me to use the routers. And after that, here again we have some switches, and also, for example, PC3 and PC4 are connected to this switch. Actually, if you want to have intra-network communication, in most cases we are using switches, okay? And also, when we want to have communication between networks, we are using the routers and also multi-layer switches. All right, we will learn more than this about these features. Here we are trying to review the functionality of the, for example, OSI and also TCP IP model. This is the first step, okay? In the first step, in the packet forwarding learning, we have reviewed the OSI and also TCP IP model, okay, and it's their relation to each other. Now let me to explain about the layer 2 forwarding. You know that when we are talking about the layer 2 forwarding, this layer 2 can be layer 2 of OSI model or layer 2 of TCP IP model. Both of them are same, but it is important to say when we are talking about the layer 2 forwarding, means the forwarding accordance to the layer 2 address. Okay, you know that in this class we are talking about only Ethernet and also Wi-Fi networks. Okay, let me to explain it here. In the layer 2, as you can see, we have two important technology, Ethernet and Wi-Fi. Ethernet is using in the wired network, as you know, and also Wi-Fi is using in the wireless network. Actually, in the ENCOR class, we are trying to learn about the communication in the wired and wireless networks. Okay, today's in the wired network, inside of the in the communication of data link layer, we are using only Ethernet and the flavors of the Ethernet, like the fast Ethernet, gigabit Ethernet, or some other things. About the Wi-Fi or about the wireless networks, we are using Wi-Fi inside of the data link layer. Because of that, in most cases, our topics related to Ethernet and also Wi-Fi. First Ethernet, after that we will learn about the Wi-Fi. But the important notation is that in both Ethernet and also Wi-Fi, we are using the MAC address or media access control. I will review it, don't worry. Okay, for hardware addressing, Ethernet is using MAC address, Wi-Fi also is using MAC address. Because of that, for addressing of our systems in both Ethernet network and also in Wi-Fi networks, we need to know about the MAC address. All right. Now, first let me to talk about the layer 2 forwarding. You have learned about them in the CCNA class. We are reviewing them, and also we will learn some new things about the layer 2 forwarding. Don't forget, for learning the network, okay, we should learn step by step. First, we should learn about the, for example, network models like the TCP/IP, like the OSI, then some fundamentals related to the layer 2 forwarding, layer 3 forwarding, and step by step we will grow. Now, let me to talk about the layer 2 forwarding. Alright, before talking about the layer 2 forwarding, let me to review the concept and also the syntax of MAC address. MAC address or media access control. You have learned about the MAC address again in the CCNA. We are reviewing the MAC address here. Actually, in each network, we need one type of address, and in the Ethernet and also in the Wi-Fi networks, we are using MAC address. MAC address has 48 bits. Okay, as you can see here, we have one MAC address, and this MAC address can be written in the 48 bits, means binary digit or base 2. Okay, but in most cases we are converting the MAC address to hex digit. Okay, because each 4 bits, okay, can be converted to one hex character. Because of that, when you have 48 bits, okay, actually you have 12 hex characters. Let me to show you here. This is our MAC address. When we are converting this 48 bits to the hex characters, we will receive these 12 hex characters. This is one MAC address. Here you can see this is our MAC address. Each system, each host, each network device at least has one unique MAC address. For example, maybe we have some device with multiple interface and they have multiple MAC address. Each of interfaces has one MAC address, unique MAC address. And you know that for uniqueness of the MAC address, we are, for example, using 2 parts in one MAC address. The first part is the OUI, or organizationally unique identifier, and the second part is the vendor assigned address, or VAA. Okay, you know that OUI has 24 bits and vendor assigned address has other 24 bits. You know that MAC address has 48 bits, and because of that OUI has 24 bits, half of the MAC address, and also the vendor assigned address has again other 24 bits, remaining 24 bits. 24 bits means 6 hex character, and because of that OUI has 6 hex character and vendor assigned address has other 6 hex character. For example, in this MAC address, as you can see, we have 12 hex character, and the first 6 characters are the OUI. This is the OUI, or organizational unique, for example, identifier. And after that, here we have the next 6 characters. And here, as you can see, this is the vendor assigned address. So easy. You know that each vendor should buy, okay, at least one OUI from IEEE, and this is a unique OUI for this vendor. For example, in Cisco, maybe one of the OUIs is this OUI, okay, and also in other brands maybe we have other OUIs, okay. Don't forget that the OUI is the unique identifier of each vendor. Because of that, the IEEE, okay, should assign each vendor unique OUI, okay. After that, each vendor can use different vendor assigned address, means different 24 bits of the vendor assigned address for each of its products. It is so easy. Also, about the representation of the MAC address, you know that in the Cisco we are using dotted triplet notation. Dotted triplet